Okay, so I want to start today with a story. The topic we're going to talk about is Telco 101. I want everyone here to understand what it takes to deliver our service, because we're in a very unique business. We had to build a software as a service platform. No different than any other marketing automation, CRM company, any software product delivered on the web. We have hundreds and hundreds and hundreds of thousands of lines of code supporting the software as a service application. That has lots of screens and lots of reports, all of the things you have in the SaaS world. We also had to build a telephone company. We have over 1.4 million numbers in our inventory of numbers. We process about 40 million minutes of phone calls a month. That is more than a lot of small cities. I'll give you a perspective on that. A very, very large call center, let's say United Airlines call center, might do 5 million minutes a month. So we are much bigger in terms of volume to the telco community than a large enterprise Fortune 500 company. And then we had to seamlessly glue these together in a way that you have the immediacy of a software as a service application with access to telephony. Because the mythology around telephony is anytime you want to change anything about your phone system, if you've ever worked for a big company, it's like a nightmare. It's a nightmare just getting a phone booth. Why should it be so hard? And so we want to eliminate those difficulties. We like to use the phrase, we reduce the friction of integrating voice into your business. Not everyone understands that phraseology, so we make it simple. We make it as easy to use voice as a business asset as it is to use a website. So let's talk about the voice side, because there are days where customers call in and they say, my call didn't go through. Now, we are not the phone company. So we don't own what in the phone company they call the last mile. That wire that goes into your business, into your home, or that cell tower that connects to your cell phone. Yet because to our customers, we're the face of voice and we want to be, we take responsibility. So I'm going to teach you today what we have to do to own that relationship. Let me put you some perspective on it. Clay, when I was your age, okay, I still remember it. When I was your age, if I made first of all, there were no cell phones. So if I made a call, there were push buttons on the phones at that point. If I made a phone call that was a long distance call, and that call dropped, I'm not even sure we used that term, if it disconnected. If that call disconnected, I dialed the operator and asked for my money back. And they gave it to me. Think about calling up Verizon or AT&T or Sprint or T-Mobile, and T-Mobile might actually do it because they're trying to be very customer-centric now, and asking for your money back every time you drop a call. So the question is, what happened between the 1970s? I'm not going to ask who was born before or after the 70s. So what happened between the 1970s and today? So the first thing that happened is that in the 1970s, the telephone industry was a regulated industry. What that meant was that you had to have a license from the government to provide telephone services. There were no ways to do it unless you were licensed by the government. You had to be licensed from the government because it was considered a natural monopoly. It means that it was going to be very expensive to run wires to everyone's home. Therefore, if you were going to make that investment, you wanted somebody to say to you, we're going to guarantee you that you have the right to be the sole provider of the service for 50 years. The government granted you that right. In the 1800s and late 1800s, the government had all sorts of problems with that, with railroads, where they did the same thing. So they were very careful when they introduced telephony to say to the telephone companies, yes, we're going to grant you that right, but in exchange for that right, you have to give us two things. Number one, you have to guarantee that you will provide phone coverage to anyone, anywhere you live. So if you live in Oklahoma, you have to be able to get a phone in the smallest town. And number two, you have to guarantee us that you're going to provide 99.999% reliability. So that's 99.999 reliability, which became known in the telco industry as 5 nines. You have to provide 5 nines of reliability. So if you're providing 5 nines of reliability, that means that you will only have one call fail out of every 100,000 phone calls. You can afford to say to customers, you've built to that standard, if a call drops, we're just going to give you your money back. And literally, there were these things called payphones before cell phones. And literally, you could go to a payphone, you'd dial the operator, and your change would come back. You know, your change would come back in the phone. Yep. So, what happened? That's what we're going to learn today. To start with, in the original phone systems were very, very simple devices. If I had 2 phones, a phone at Sally's home and a phone at John's home, there was a wire, a physical wire running from Sally's home and from John's home to a switchboard in the middle of the town. And sitting next to that switchboard in the middle of the town, we've all seen the old movies, was usually a woman with a gray bun on the top of her head. And Mary would, when John or Sally, whoever this was, dialed their dial, a bell went off in this switchboard. And a light went on next to that wire. And Mary would connect, say, John, who do you want to talk to? I want to talk to Tom across town. Okay, I will patch you in. And she connected a wire between Mary's phone wire and Tom's phone wire. So once that wire was connected, unless somebody took a plow and ran over this wire, that phone was always going to work. Now, things got a little bit more complicated when you wanted to talk to Sammy, who was in New York City, or to Aaron, who was in Boston. You now know 2 of my sons' names. Because your operator actually would call an operator in the other city and would say, can you give me a line to your city? And then that operator would put another patch cord on and connect to Sammy. So if you were in LA and you wanted to call New York City, your operator might say to you, I'll ring you back when I get a free line. Because there were only so many wires running between LA and New York City. And in the very beginning, it was even worse because the wires weren't capable of running a single wire all the way across the country. So you'd run, let's say to go from LA to New York City, you might have to go through 3 or 4 switchboards. And so people would call you back when you can make a long distance call. In fact, even later than that, because this probably takes us to the 20s, even later to that, into the 40s or maybe the 50s, depending on where you were calling overseas, the same thing applied for overseas. You wanted to make a phone call to Sao Paulo, there were only so many wires under the ocean. Okay? Now, at this point, we were getting fantastic reliability. But then things started to change, and the first set of changes were really very, very good. And those sets of changes, well, they were good for the telephone company. They replaced the patch panel there with electronics. First, electronic tubes, and then transistors, and then integrated circuits. Unfortunately, Mary lost her job. But there were still these big buildings with switches in them. So you drive around any major town, and you'll see like buildings that are often brick buildings that have the telephone company name, Pacific Bell or Cincinnati Bell, on the outside of the, and there's like no windows. And maybe you see some telephone company trucks in the parking lot, and you're thinking, what do they do there? What they do there is that's where the switches are. So there are still switches every so often, but now with electronics, when you place that call, those switches can auto-connect to the next location. So that takes us all the way to the 1970s. And in the 1970s, when I was your age, 70s into the 80s, we were still getting 99.999 reliability. So what changed? How many of you have, or your kids have used walkie-talkies? Okay, you get them at Radio Shack. You know, what's the experience like? It's staticky. If you go too far, it doesn't work. If you're around the corner, it doesn't work. So somebody had a real, and it's no different than a radio. Walkie-talkie is a radio. So think about even the satellite radio today. It's very interesting. You go under a bridge and your Cirrus goes out because it loses the signal. Satellite radio is actually more susceptible to some types of interference than the old AM/FM radios are. But you know, you're driving cross country, you're driving from Cincinnati to San Francisco, and you have to keep changing before satellite radio stations because you'd get out of range, right? So radios have all sorts of constraints. You can get a good signal, a bad signal, it can work, it cannot work, all sorts of constraints. Somebody had a brilliant idea. Let's connect walkie-talkies to the phone system. And that was the first mobile phone. So a mobile phone is in essence, so that's actually a little bit of magic. I have a doorbell on my house that when somebody comes to the door, if I'm at home, I can actually look and see who it is and talk to them, okay? It's a $200 product. It's not a big deal. Anybody can do it now. So that was my doorbell ringing. I'm pretty sure my wife's home, and she'll get it today. So, bless you. So somebody had this brilliant idea to connect walkie-talkies to the phone system, because that's what this is. This is a radio. Now, it's a radio that's smart enough that you don't have to push a button when you want to talk. It senses you're talking, but it's a radio. That means it has a transmitter, it has a receiver, it's a radio. So to connect this radio, what I need to do is I have to put up a radio tower. Today we call those cell towers. And I'll explain why a cell tower is different than a regular radio tower. But with the first cell phones, they were radio towers. They were transmitters, receivers of radios. And that radio tower was then connected to the switch. And then somebody driving along in their car connected to the radio. Okay, now, just like that walkie-talkie, you get out of range with the very early mobile phones. You're driving along, and if you got too far from your radio tower, you drop the signal. Now, clearly, that wasn't optimal. So they came up with an idea, which was called cell phones. What a cell phone does is, instead of connecting to a single radio tower, a cell phone has the ability to sense multiple radio towers at the same time, and to determine the distance or the quality of the connection to any given radio tower. And it'll connect to the primary one until it gets too weak, then it will switch over to the next one. So that's why you can drive very long distances on your mobile device, on the train, whatever, and you don't drop the signal. Okay? But think about what this did to reliability. We can't give these guys 99.99959 of reliability because they're on walkie-talkies. So the cell phone companies went to the government and said we should be exempt from the quality standard. And they received an exemption. Different service, they received an exemption. In fact, there is no government requirement for cell phone companies to meet a certain standard. So, do you know what the standard is that they publish nowadays? The only way we know this is because when AT&T tried to buy T-Mobile, they had to release for public review all sorts of documents about why they wanted to buy T-Mobile. And a set of the documents they released said they want to buy them because they want access to their cell towers because they recognize they need to improve their quality. If you remember, a number of years back, Verizon was killing AT&T on quality issues. And their goal for quality, not where they were, their goal for quality was to take their quality all the way to 99%. 2 nines. That was their goal for quality. Okay, so let's do the arithmetic. If I have 2 nines, 99% of quality, out of every 100 phone calls, not a lot of phone calls, how many failures are you going to have? You're going to have a call fail out of every 100 calls. That's why we have the experience we have. Okay? So we went from 5 nines to 2 nines, which is why there is no way they're giving us their money back. If they recognize that 1 out of every 100 calls may fail. Now, it would seem that this all is going to work pretty well. Okay, you have multiple cells, maybe they'll be able to improve it if they have enough cell towers, enough places to put antennas. There's a problem. These are radios. Radios have a capacity. So maybe a radio cell tower can handle 100 simultaneous calls. Okay? So you're happily on this cell tower, it has 50 calls. You're driving around, and you decide your system attempts to connect to this new cell tower that has 100 calls on it already. You go to switch from this one to this one, and it's not that you don't have a signal. You look at your phone, you have 5 bars, but you dropped the call. Why did you drop the call? You dropped the call because this guy was already busy. He didn't have any room for you. Okay? So by introducing walkie-talkies to the phone network, we created a whole series of reliability problems. Then we made it worse. Okay? How many people have been in a web browser? You're in Safari, you're in Chrome, whatever. You go to a website, you go to a URL, you bring up the page, and you get half the page. It's clear something's wrong here. Okay, so what do?
Refresh.
Okay, right, you hit refresh. Okay. Do you have a refresh button for phone calls on your phone? Okay, so somebody had another really brilliant idea. Actually, a company called IDT were the very first guys to do this out of New York City, and they did it between New York and the Middle East. Okay, and what they said is, there are a limited number of wires that run over the ocean to faraway lands. So that's why international phone calls are so expensive, because you're renting part of that wire. So let's find another way to do that. And what they said is, in today's world, because of a glut of fiber that was put in the late 80s, it's actually cheaper to connect over the ocean for web traffic, for internet traffic, than it is for voice traffic. So let's rely on the internet, and let's connect between a switch and a gateway, an adapter box. Let's connect to the internet. And then we'll convert that voice into internet protocols, and we'll send those packets of information across to our destination. And we'll have another gateway kind of box, and we'll connect that to our telephone. And a good way for you to understand that is think Vonage. They give you a little box. That little box connects to your telephone. And on the other end, they have effectively a lot of little boxes. They have big boxes that can handle many calls at once. But all they're doing is converting your signal from your phone into internet protocols, and those internet protocols go over the internet, like anything else over the internet, and then connect back to a phone switch. So what happens when you get that partial page load, but instead of it being a page, it's a word you just said? It means that the quality of that conversation is not as good. The acronym for this technology is Voice over Internet Protocol. That's all VoIP is. It's just Voice over Internet Protocol. Okay, so now let's look at this whole story here. We have a walkie-talkie on one end, connecting to a radio that may be near capacity, then going to the phone switches, going over the phone switches, then connecting to the internet, and going to a phone over the internet that's in Germany, maybe somebody on a low-cost DSL that has terrible internet service. And we wonder why we don't get 5 nines anymore. Now, if this was one of our customers, and they're on a cell phone, and they're connecting to a business that we're servicing, and the business says, I got a call from all of my customers in Des Moines are calling me and saying, when they type numbers into their phone to navigate one of our IVRs, it's not working. Where's the problem? Could be a problem with this radio antenna. Could be a problem with one of these switches. Could be a problem, maybe that business is using a VoIP circuit. Could be a problem with their VoIP provider. Could be a problem with the phones those customers are using. Complex problem. Now, where does If by Phone fit into this picture? So, If by Phone the If by Phone infrastructure is physically, the majority of it is physically in a data center in Elk Grove Village, which is by the airport. It's one of these massive, all-concrete buildings. It's 4 stories high. It's run by a company called Equinix, which is actually the largest data center provider in the world now. Our next-door neighbor is on the floor above us is all Career Builder. That's where all our servers are. The 2 cages next to us are labeled AT&T. We don't know what's in them. But we rent basically space that's maybe double this size, that's in a locked cage. Literally, it looks like a cage around a playground, except it goes all the way to the ceiling, in this building. You go to that building, because it's what's called a Tier 1 data center, it has biometric security. So you go to the building, and you go in a glass door in the front, and all you see is a pedestal with an outline of a hand. It's the freakiest thing. Because you're in security, you've seen this. You put your hand on the pedestal, and a blue light goes zzz, like the Starship Enterprise. You're entering the bridge. Okay? And a door opens up, and you find yourself in a corridor a little longer than this, but half this width. It's called a man trap, actually. And behind a glass door, you have some guards. Actually, don't look that scary, but they're behind really thick glass. And they're actually verifying that the picture that came up is the picture of the person whose hand was on that. And I guess they're verifying the hand's still attached to the arm and those things also. And if that works, they give you access to the facility. You put your hand in again, you put your hand in to get in the elevator, and then you put your hand to get into our cage. Because we are handling telephony data. We get subpoenas every month from the FBI for various things. We have to provide a certain level of security. That data center, up until about a year ago, we were connected to the fabric of telephony, literally, by connecting to the internet. Now, we didn't have internet connections like you would have at home. These were fiber optic connections. They were very fast. They were much more higher reliability. But all of our traffic was effectively going through gateways on both sides. So all of our traffic was going out over VoIP. With the exception of, we have the capacity to handle about 1,000 simultaneous calls over traditional, directly connected to these switches. We use that for testing purposes, for backup. If we have a particular location we're having trouble with, we send those calls over what's called TDM, the traditional dial network, in order to verify that it's not something related to this. Within the last year, the majority of our traffic now actually goes through a special gateway. It goes through, let's call it a segregated part of the internet, because it's directly connected to level 3. And the circuits that level 3 uses are part of the internet fabric, but they're separated for their telco clients. So we're really now private connection, but we're still sending all of our traffic over VoIP. Okay. Level 3 is called the telephone company's telephone company. The average consumer has never heard of them. They're almost as big as AT&T and Verizon. They're much bigger than MCI and Sprint and T-Mobile and all those folks. And in fact, we are treated by them as a carrier. So we buy from level 3 the way Sprint buys from level 3. Because Sprint doesn't own any landlines anymore. They sold that all off. So if you're on a Sprint or a T-Mobile cell phone, to get connected to phones that are not cell phones on their networks, they have to buy interconnect capability from a vendor. They buy from level 3, just like we buy from level 3. Now, inside here, it's very, very complicated. There are probably, between our 2 facilities, Cleveland and Chicago, because we do have a data center in Cleveland now, between those 2 facilities are probably close to 500 components. Okay? I know for a fact there are a few hundred servers. In Chicago alone, I know there are over 150 servers, and we're going to be adding 40 to 50 more this year. So there's a lot of stuff. Now what happens is that a telephone, interestingly enough, is actually 2 separate devices. We think of it as one, but it's 2 separate devices. The keypad is one device. The voice part is a separate device. So in the old movies, you saw people, ring a crank that would ring a bell in the switching office. Well, when you type something on the keypad, that's in essence what you're doing. You are sending a signal, it's called the signaling side of telephony, over that side of the telephone network. That's separate from the voice side. So what happens for if by phone is when a call comes into if by phone, it comes into a series of switches, running software, and this is trivia, you don't really need to remember it, running software called SER, Session Exchange Router. SER is an open source project that was funded by the German government, by the West German government, because they got tired of having all their companies pay people like Northern Telecom or Sonis an enormous amount of money for these telephone switches. So they went to the university world and they said, we will fund you to build an open source phone switch. That's how we do our switching. So somebody dials a phone out here, it routes all the way through here, it comes to our SER component. And that SER component determines whether this is a call to one of our customers. If somebody somehow gets a call over these wires that's not to one of our customers, we give them a fast busy like you would dialing any other number where you see here the beep, 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 beep. Okay? So we're acting like a phone company at that point. Once we accept the call, we identify what customer is responsible for that call. Because a lot of our business is, we provide telephone numbers to businesses, they publish them places, when people call them, we decide how to route and forward those calls, and then we put a lot of analytics and measurements around it. So these SER boxes talk to a bunch of databases over a component we call the controller, which is also trivia. And then they hand the call off to one of 2 types of components in our network. Okay? One type of component in our network is able to handle basic calls. So what is a basic call? Someone calls in, track the call, and forward it here. So the consumer is never interacting with with a computer. It's not an IVR, it's not leaving a voicemail message. The consumer, the caller, is never interacting with any intelligence. We're just connecting a caller to a recipient, and then we're measuring everything in the middle. We call those basic calls. We do basic calls at If by Phone, Chicago. We do basic calls at If by Phone, Cleveland. For all practical purposes, the Mongoose platform only does basic calls. Okay? On the If by Phone Chicago, the If by Phone side of the house, though, we also are able to do something called smart calls. A smart call is when there is a computer interacting with the caller in a very dynamic way. So a very simple example of a smart call is you call a number, and that call does a find me. It tries 5 different numbers until it locates the person. Think Google Voice, okay? So our find me is like Google Voice on steroids, okay? So it does a find me, and as part of that, during the course of that call, and if you've called my main business number, you'll hear this. You'll hear a message that says, I'm going to attempt to reach Irv. If you wouldn't mind, please say your name at the tone. And you say your name, and then I'm actually hearing on the other end, you hear some pretty music. I'm hearing it's a call, and it's a call from Marta, and because I hear your voice, and I have the right to accept or reject that call. Okay?
What are you going to do?
And so I accept that call because if I reject it, you'd go to my voicemail, or you'd go somewhere else in our system. I could unreject, have you go to a different person, go to my assistant. All of that intelligent handling is provided by a smart server. Okay? Now, the reason this is important for us as a company is a basic server is basically, let's say it's $1,000, and it can handle 70 to 100 simultaneous calls. Historically, when we got started, the smart servers we used were on the order of $30,000. So we had a lot more of these than these. Anytime we could use one of these, we wanted to use these and not one of these. Now, these were so expensive because in order to provide that intelligence, we needed an operating environment. I'll give you an analogy. If you're using a database, you've heard of the company Oracle. You can buy a database product from Oracle, and they'll charge you, I don't know, $30,000 a year, $40,000 for a license for Oracle. Very good product, big company, run by a lunatic, but a good product, okay? Or in today's world, many of your customers are using things like MySQL, or Hadoop, or MongoDB. These are open source, okay? They're not paying licenses for those. They don't get all the support, they don't get all the hand-holding, but it's a different environment. So originally, the equivalent of the database, the voice interpretation layer that we put on these systems, we licensed from a company called Voxeo. Okay? And it's a product called Prophecy, which you'll hear about too. And the licenses for a server were about $30,000 a server. We have over $1 million of Voxeo licenses. Okay? We have a lot of servers now doing that. And we realized about 2 years ago that it was going to limit our ability to grow rapidly. So we started an R&D project to look at what it would take to, in essence, build the equivalent of building our own database. Instead of using Oracle or even MySQL, we're going to build our own. So we found a little company in Seattle called CloudVox, and we literally bought them because they had some base R&D that we wanted to acquire. And then over the last 2 years, we've built out a new platform called Phoenix. So if you hear about Phoenix, that's the Prophecy replacement platform. And today, about half of our smart volume now runs through Phoenix. By the end of this year, almost all of our smart volume will run through Phoenix. Phoenix has no licenses because we own all the IP. So long term, from a liquidity point of view, it puts us in a much stronger position. long-term, it creates a real barrier to entry to doing this type of smart processing because we're able to do it at a much lower cost point than somebody who's just going to license an interpreter. It gives us IP. We actually have patents around a variety of the things we did there, but other pieces are handled by open source software. So now, this caller on the walkie-talkie connects all the way through. They get to an SER server. We look up the account. They want to go to an IVR, which is an interactive dialogue between a consumer and our computers, are acting like a receptionist. That goes to a smart switch. The call drops. Where did it go wrong? So that's our biggest challenge as a company. And that's our biggest strength. Telephony is messy. When things are messy and complex, if you can provide great service and support, you own your customers for life. You own them for life. So one of the questions you'll be thinking about as you think about If by Phone in the future is you'll be thinking about a West Coast firm that sounds like it maybe does something similar to If by Phone. They're called Twilio. Probably a name you've heard. The Twilio infrastructure looks very similar to our infrastructure. Okay. The difference is Twilio doesn't build any pre-built applications. They give you a toolkit to build all the things we've built. IVRs, voicemail, Find Me, voice broadcast. They give you a toolkit. So the way I differentiate Twilio from If by Phone is in two ways. Number one, Twilio is a lumberyard. You go to Twilio, you pick up whatever lumber you want, you can build any bookcase you want. Okay? If you were in college, you buy a couple cinder blocks and a board, and you're set. You are happy. Okay? Now, as you progress in your career, you're busier or whatever the case may be, maybe you just don't have the time, and cinder blocks and boards don't cut it anymore. So now you move up the chain. Maybe you go to IKEA, maybe you go to Room and Board. Where you're buying Room and Board, you're buying modular bookcases that they can connect together in different configurations. You can pick the layout, you can pick the configuration, but you can connect them together however you want. Now maybe later in your career, you decide to go to Neiman Marcus and have a personal designer design your wall unit for you. So there's a continuum in everything you do. We're at the middle. We sell modular, pre-built applications that do call tracking with analytics, call routing with IVR, call management, which is virtual call center, and outbound notifications as pre-built applications. And we give you a set of tools to connect them together however you want. You go to Twilio, you have to build all those applications. You get boards and cinder blocks. You go to Genesis, a very large company that sells to large data centers, you're going to spend $1 million. But they'll build you anything you want. Okay? So we're in that middle space. Another analogy would be if you wanted to create a CRM for your company, a customer relationship management system, you could go to Amazon AWS, you could rent server space, you could download a free copy of Sugar CRM, which is open source software, you could load it onto Amazon, you could connect it together, build whatever you wanted. You own it, you get no support. Amazon, the AWS people are not going to tell you how to do it. Okay? They're going to give you the resources. Or you could go to Salesforce. And Salesforce has a pre-built application, but with a very sophisticated API, so you can connect it together to your current systems. So we are the Salesforce of voice. And Twilio is more like the AWS of voice. Okay? So there will be customers that want to build it all from scratch. They should go to AWS. There will be customers that want it to work and want their support organization to actually answer the phone. Twilio charges you $3,000 a month if you want phone support. We provide phone support for every customer if they're paying us $50 a month. So this is called Telco 101. This is very complex stuff. That's our strength and our barrier to entry, is that we're able to do very, very complex stuff, and we mask all of this from our customers. To our customers, we look like another SaaS application. When you go and you create an IVR, I don't know if you've seen creating IVRs yet, but you create an IVR, you create a Find Me, you set it up, it's live instantly. There's no waiting for the telco guy in the corner closet to come out and make something happen. As a marketing manager, you can now take complete control over voice. You can do very complicated things without even having a voice infrastructure. Your whole business could be run on cell phones with If by Phone. And If by Phone provides the glue that connects them together. Okay, any questions? No questions? Completely confused or not too bad?
Not too bad.
Yeah, I mean, it's really, really interesting. So you said that all the information that you provided up here is all hidden from your customers. So is there any, I mean, it's, the inner workings are very interesting. Is there any reason why you wouldn't want to tell the story?
We're happy to tell the story.
Okay.
We're happy to, you know, I believe in great tech companies. Trade secrets make no sense because the hard part is not knowing what you did. The hard part is doing it. Connecting together all this stuff is really, I can tell you what every component is in our network, and if you were Google with a team of people, it would still take you multiple people years to recreate what we had. Which is why you see companies like Google and Apple buy these little companies. You would say, hey, they have all these, why don't they just build it? Well, guess what? Knowing what they built and building it are two different things.
Yeah, it's interesting.
Yeah, so no reason to not share what we're all like.
I mean, I think it'd be a, kind of an interesting chalk talk.
Mm-hmm. Could be a different type of series. It could be, yeah, absolutely.
I have a question about when you were giving examples of Twilio versus Genesys versus If by Phone. So as we move upstream, we want to sell to the enterprise, we want to sell to the larger customers. Obviously, that's cool.
Mm-hmm. Why
would a big company want If by Phone versus Genesys if they could afford it? Obviously, a lot better price point, but
it's a price point decision.
Okay.
So a big company can choose Salesforce, or they can go to Oracle and use what used to be called Siebel, Oracle CRM, and install it on-premise in their data center. And big companies, because they don't want to support the on-premise in data center stuff anymore, are still going with Salesforce. Genesys is basically an on-premise data center, call center infrastructure that's optimized around having all your agents in a giant room lined up in rows.
Got it. Okay.
So, would we fit, can we fit every enterprise application? We cannot. We cannot support a 5,000 person call center. Our application doesn't scale to that level. Our top end is probably about 500 people in a call distribution environment.
Okay, makes sense.
How do you see that changing over time in terms of you have individual landscapes like VoIP and cell technology that are changing on their own, let alone new technologies coming in? I mean, where do you see the next 5, 10 years?
I see the phone as a device completely disappearing for many of our customers. We have a project underway that's in test now that should be live at the end of the quarter, where if you're running Chrome as your browser, which means you could be on your Macs, it is interesting that 100% of the people in these conversations are on Macs. You could be on your Mac, you could be on your Chromebook, that's a $200 computer, you could be on your Android tablet, then you would be able to plug a headset, that headset into your computer, and your browser becomes your phone. You wouldn't need a phone at all. You wouldn't download a soft phone. You wouldn't have to go into Skype separately. You'd go to a page that's powered by If by Phone, and that page is a phone. It's a website and it's your phone. It's all in one. You'd be able to accept calls from your customers right in your browser. So I see us becoming even more device agnostic. Even more device agnostic. Cost structures are continually changing. I literally was on the phone at 8:30 this morning negotiating our next contract with Level 3. We don't use them for 100% of our volume, but we're negotiating a $9 million contract for the next 2 years for their portion of our volume. And we have leverage at this point, and so it's a bit of a dance. So I see costs coming down. I see these components continuing to evolve. Today, we use Asterisk, we use in Cleveland, they use the version of SER called OpenSIPs. In Chicago, we use the version of SER called Camellia. I see there being movement, platforms coming together, picking best of breed. So I think we have to stay on top of this stuff. We cannot fall behind. You fall behind and you're toast. So the primary change is going to be that the way you communicate by voice is going to change. Now we saw that already happen with texting, because the percentage of text messaging that goes over WhatsApp and iMessage that doesn't go as SMS any longer is actually larger than the SMS traffic. So we saw things switch from the telco side to the application side. We're going to see the same thing with voice. Already, I believe Skype is the largest international telephone carrier in the world. That they do more international phone calls over Skype than are done by the telcos, country to country. So I think you're going to see that continue. Good?
Good.